Hey, good afternoon, everyone. My, my name is Sanjeev Khanna. I work for MCIO, which is Microsoft Cloud Infrastructure and Operations team. And the job for our team is to basically deliver enough capacity in data centers that all the diverse services that Microsoft delivers, like Office 365, Bing, Microsoft Azure, they all run on the services that the team manages. And as you can imagine, we are diverse, globally diverse also. We're running more than 100 data centers in 40 different countries, which adds up to be more than a million servers. So what I'm going to focus on today is what is the supply chain challenge for running that type of infrastructure. So if you're a supply chain guy, actually your life is pretty easy because you only worry about two things. You have to worry about continuity of supply, and you need to worry about the total cost of ownership. Everything else is someone else's job. So supply side, and I'm going to mention this a few times during the talk, unpredictable demand is one of the major things that we deal with. And the reason for that is, right, that people have been doing on a retail side many, many years, and they figure out a seasonality. Q4 is going to be high, Q1 is going to go down, Q2 gets bigger, Q3 gets bigger than that because you got back to school, and then Q4 is back out again. On a cloud side, we haven't figured out what that predictability is at this time. And then you add the geographies, because every place has a different Q1, Q2, so that makes it even more complex. And then you see a technology on both sides. It's under continuity of supply. It's also on the TCO side. From a continuity of supply point of view, technology is what we got to manage. Even though our base infrastructure, meaning the servers and the racks and sheet metal, that's pretty stable, but the components, the key components like hard drives, the memory, NAND products, they all change frequently. And not only they change frequently, they change at a different cadence. So what you got to do is you got to manage that we don't end up with excess and obsolescence, or our suppliers don't end up with excess and obsolescence. But on the TCO side, most of times when you go from technology A to technology B, you get a better price per unit. So given those two things, it's kind of a conflicting thing that we got to manage, and it makes our job more interesting. When we look at TCO, we're not looking at acquisition cost only, because acquisition cost is easy and very important to know, but at the same time, we want to look at our operations cost. And when I say operations, a few things you got to consider is, right, power. Again, power, you go, okay, someone's 2 watts high, 2 watts low, you can do the math on that. But then there are other few things that we are trying to bring into our TCO model is quality, which you don't know till you deploy this product. And after you deploy the product, and 3 months from then, or 6 months later, or 18 months later, if it starts fall apart, you got to bring down your infrastructure to replace those parts. So you have to be careful on how we do quality. Again, I can get a very good acquisition cost, and if supplier performance, delivery performance is not there, it doesn't help us, because I got something cheap, but I cannot get it. We got to go manage that. So when we were looking at the continuity of supply, we started building this framework last couple of years. And the things that we looked at is, right, that the yellow side is basically any business continuity planning folks are looking at. It's the geopolitical risk, it's the market industry risk that we got to go watch for, we got to go build that. But then the other piece is, as I said, we don't know how to forecast. Our demand goes up and down pretty significantly. So we got to go build in our systems, how do we go manage with our forecasting? So what we're doing is, after a pretty healthy internal debate, we said we got to go build our systems which address both sides. And some of the things that I'll talk about, the multi-pronged approach that we are taking to address that risk. So it starts with innovation. We have to innovate. But we got to be careful that innovation is not done, that our engineering teams build something which we cannot deliver. So DFX, designed for cost, manufacturability, quality, all those discussions need to happen. Designed for operational efficiency. You can design something really nice and complex, and when it comes to operations, you cannot operate it well. You got to worry about that. Then standardization is one thing that we are driving, and that's an internal standardization and external standardization. Standardization is the only way in our environment we can bring some kind of agility and predictability in our system. And the last one is strategic partnerships. We're working closely with partners, and we need to continue to have that engagement. So look, some examples on innovation. So last 12 months, we have done the second version of memory innovation, or M.2. We've done a second version of OCS chassis managers. On top of it, you heard Mark, you heard Kushagra talk about Sonic. So pretty exciting what we're doing on the networking side now. And then we looked at our portfolio. We said, oh, we needed a full-length blade. So we did another blade, which is we're using for storage blade. So DFX, this is an interesting thing that we've been kind of looking at. If you look at the tray backplanes on the one on the top, that was the original design. Just look at the number of components we have on that. Team looked at it, team looked at the functionality we need to have, and redesigned the same part, which has exact same functionality, maybe even more, but a lot fewer components. That's an example of where we're looking at it, reducing cost. We're looking at improving throughput. Next one is we looked at our field data, and we found that PSUs, after 90 days of deployment, had a pretty healthy and were not failing. So based on that data, we did a deeper analysis, and we were able to reduce our PSU runtime from 4 hours down to 1 hour. So again, it's a cost saving, it's a better throughput at our suppliers, and we can continue to kind of get that better. Last thing is our mechanical team has been very thoughtful about what they design. So reducing how much metal we need, because the less metal we have, the less we're sending to landfills. On top of it, it's a cost. Not only are we paying less for the metal, but every time we have freight moving from geography to geography, we have to pay less for that. Operational efficiencies. So it's net it is, right, that we can do warranty management, because essentially the systems that we have designed, even though we have different service providers, they're all same or very similar. So we can manage our warranty better. Inventory, we can share some of the inventories, because in the past, every system looked different, so we couldn't share any inventory. And the last thing is our operators are getting trained only once to manage those systems. So that helps us to basically have a repeatable process, so we can deploy faster, we can debug faster, we can bring stuff back on faster. Standardization is, like I said, the only way we can bring predictability in an environment which is very unpredictable. On top of it, on the supply chain side, the agility is going to be through internal and external standardization. So internally, what we are trying to do is we have started reducing number of SKUs we have. We've gone down from almost 80% from when we started the journey to where we are. We're not done yet, but it's heading in the right direction. But we can reduce, there's never a case where we're going to have only one SKU, because every different environment requires a different SKU. So what we're looking at is fungible building blocks. So we can bring together these building blocks for, let's say, Microsoft Azure, but then use the same or similar building blocks which are going to be used for search. So that's the piece where we are driving the standardization, where we can leverage the same building blocks and deal with the spikes in our demand. Externally, from start, we have started to use 19-inch racks because we don't want to drive yet another standard which is only for Microsoft. So last one, what I look at is, and probably the most important one, is the strategic partnerships that we are building. We're not talking to suppliers just about cost. It has to be about the technology. Microsoft is very open sharing on what we need, where we are heading, and let the suppliers help us build that technology. On a supply side, we're not only talking to the system providers, the end system providers who are giving us the SKUs, but also talking to the component suppliers and sharing the forecast that we have. Again, I already said we don't know how the forecast is changing, but if everyone has the same information, they can plan for it accordingly. And TCO, back to acquisition cost is very important, but please think about the operationability. So with that, what we have been doing is the engagements that we have put in place for the last 3-4 years has enabled us to deliver a pretty good ecosystem. And if you look at it, what we talked about last year to this year, this ecosystem has grown, and this will continue to grow as we continue to develop those relationships. So interesting thing happened. Not only that some of the system providers, by working through us, working with us, are delivering to us, but they have taken upon themselves to productize the SKUs themselves. So here are the names of system providers where you can buy an OCS-based SKU. You have the names of their model numbers, there's the contact names, and you can reach out to them if there's an interest. They can provide you with the systems which are based on OCS. So in the end, we've been enabling the OCS ecosystem, and the request to you is, or the opportunity for you is, that you can leverage the work we have done, and we can continue together build that system. That's all I have. I got my signal. Thanks.